Talking of hedging of exotic options. Now, again, hedging of a portfolio of options is a very important activity, because then we have studied different kinds of Greeks in our other video as well. So that way, Greeks are typically those parameters which a dealer might use in order to measure the risk of a portfolio, and also they might want to hedge it accordingly. Further, there can be limits which can be set on different risk parameters, and those have to be kept in check. So that way, hedging becomes a very important activity, not just for vanilla portfolios, but I would say for exotics as well. Rather, I would say they become more important when we are looking at exotic options. Now, I would say not all exotic options are difficult to hedge. Some of them are fairly straightforward, like we see here in the first example. So let's take an average price option. So such that in this, as the maturity approaches, we know that more and more of the asset prices are used to calculate S average will now be observable, isn't it? Because then as time passes, we are able to view what are the asset prices, and when we compute the average price, as we come close to maturity, we become more and more certain as to how the payoff is going to pan out, isn't it? So because of this nature, we observe that the value of this option will generally be less sensitive to the asset price movements occurring late in the life of the option, because then we are able to see the evolution of the asset price, and then we are using it as a part of our calculation. So that way it becomes a little easy in order to hedge this kind of option. Now, in contrast, take an example of a barrier option. Now, barrier options are difficult to hedge because they have a discontinuous behavior across the barrier. So, out of the many strategies which dealers might use in order to hedge a barrier option, one very popular strategy is what we call as a static options replication, which is used for hedging of barrier options. So let's discuss this static options replication strategy. It's very interesting and something which is very popular amongst market participants. So what is this static options replication? Let's understand. Now, the main idea underlying this particular hedging strategy is if there are two portfolios that are worth the same on a certain boundary, and typically the boundary is something which we'll say is a function of asset price and time. So if you have two portfolios which are worth the same on a certain boundary, then they should be the same at all the interior points as well. So we can say that we will need a portfolio of multiple vanilla options that are worth approximately the same as the exotic option on the boundary. And if you're able to have such a bunch of vanilla options, then it will allow us to hedge the exotic option by shorting this portfolio of vanilla options. So for example, let's take an up and out call option with a strike price of 30, a barrier level of 50, and let's say that the current stock price is USD 25. Now it's an up and out call, so we can imagine that it's like a knockout variety. So if the stock price hits the barrier level, the option is going to get knocked out. We have seen the barrier option earlier, so this is just a design on the similar lines. So we can visualize it through a diagram like this. So you can see the diagram below. We'll go through the steps, but look at the diagram first. So we have the total time to maturity up to 1 year, so 0 to 1. So we have the time axis as the x-axis, and we have the asset price along the y-axis. So we have the boundary of 50 which has been set. Now, as we know, the strike price is 30. So the boundary where that value of strike price will be considered will be used in your payoff computation. So you'll have max of S minus 30. So we are looking at this vertical boundary. And then on the horizontal boundary, the value will be 0 because then it's an up and out option. And if it hits the barrier, then we say that the option has got knocked out. So let's walk through the steps and understand how this replication strategy can work. So we'll use a 1 year European call option with a strike price of 30. So this is going to match the vertical boundary because then we have an option which matures exactly at the 1 year time point and it will have a strike of 30. So using our usual vanilla call payoff, we are able to match the payoff on the vertical boundary. Now to match the payoff on the horizontal boundary, we will choose n equally spaced points. So let's say I'm just showing 4 points, but let's say they're n in number. And this will require additional n European options with respective maturities which are less than 1 year. Because if you see, the 1 year point has been taken care of. We have to look at all the earlier time points. So we look at n European options which have a maturity of less than 1 year, and we'll value each of these options. Now we are expected to solve a system of simultaneous equations, because then if you see, we have certain number of n options which we are looking at, and if we are able to solve these equations simultaneously, then this ensures that the portfolio which is created from all of these options, or these vanilla options, will have a value of 0 at each of the n points on the horizontal boundary. So this is going to allow us to do the hedging which we are looking for. Now, if you were to look at mathematically how we can represent the above steps. So let's say C subscript J is the value of the 1 year European call option with a strike price of 30. And this is at the jth point on the horizontal boundary. So this becomes our starting, the first option. Now, as we know, we are going to step back a long time. When I say step back, we are looking at options with maturities which are lesser than 1 year. So let F subscript ij be the value of the ith additional option at the jth point on the horizontal boundary. So we are going to look at each of those n steps prior to the time point 1 year. And let ai be the size of the position in the ith additional option which you are looking at. Now here ai, the amount of ai will be determined by solving a system of n simultaneous equations. It can look like this. So you have Cj, which is the first option, and then we have a bunch of these other options. Now, as one can expect, as we increase the number of vanilla options which we are using, that is, as we increase the value for n, then that means we are able to match the horizontal boundary much more closely. And if we are able to match it more precisely, then we are able to create a better hedge, i.e. the hedging performance of the portfolio improves.